All right. So, to assist you on holding on the ends of the tape, so if it's just you that was going to be doing surveys, you can either use these, which are survey arrows, so you can whap the end of that in somewhere. At least you can pull it straight.
Look like the Java.
Yeah, I've banged in little nails where I need them so I can pull the tape straight. And then you can also, which some of you might have, is a disto.
Yeah.
Right, a disto. So there's a little red dot in there. You can see it?
Nope.
Yep. Oh,
Yeah.
Oh, you're like a sniper.
And it gives me the distance from where it was, 1.133.
Oh,
All right?
what is that? Right.
It's a disto. So it's the same as a type, it's electronic.
Oh, is that laser?
Yeah, but when you're over a long distance, if I put it on that wall, can you see it? I can't see it.
No.
So therefore, you could take the distance, right? 3.959, but you don't know where it's taken to.
Yeah.
So you can get glasses that put on that help you. And this one has got a little bubble on it. And my brother's got one where you can actually look along it and see what you're looking at. So they are quite good, but they're quite expensive.
How much?
I looked at the next version of this and it's 350 quid.
Oh, I'll get a couple.
Okay,
I'll get a
later.
couple.
I'll eat one now and keep the other one for later. All right.
Wait, so the pikeys can nick it.
Yeah. Right, so what we'll do is we'll lay out a tape. So if I can have one of your types. Right, so I've banged in a little nail here because again, you would tie this round the end of a brick or something so that you can pull it tight. Right, and this is going there. So if you look at your plans,
Yes, this is not bigger. Oh.
if you look at your plans, I'm going from, who's got plans? Right here. So I'm going from this point, which is point F, to point G. All right?
This is
Yeah.
the house here. Point F to
Yeah, you have.
Wait, yeah.
Well, use this one. So I'm going from point F, it's a little nail, to point G, all right? Cool. And that's going to be a baseline, all right? So I'm setting out a baseline and we'll take measurements off of that by offset and by trilateration. And we'll see how accurate, because I've written the dimensions on here, 7.62. So if we go along 20 metres along this type and go off 7.62 to the corner of that window, we'll see if it matches.
No pressure.
Triangulation is generally a baseline in angles when you build the whole thing up angles, but trilateration is only distances.
Red line
On the plans
to any
inside.
given plans.
They should be, well, you can pinch one of them big, but
To this point here,
there's 4 plans in there. One of them's got the dimensions on that, so pinch one of the ones inside. Right, everybody move out the way so I can get straight. More. Get your feet out the way, yeah. Right, the distance to that is 24.87. 24.87. So who's got a map? See what it says.
No, but that's not a real measure.
24.87. 24.89. All right, so if I pull it a bit, no, we're going to here.
24 metres.
Right.
24,000.
Let's say probably 8.5, maybe 8.4. There's a little nail there, measuring to. Huh?
is that the one? 2489?
Yeah. It sets 2489.
Is it that one? No. That one, yeah.
Yeah.
All right. So that's taken off it, and I've measured it. Now I could gain or lose a little bit where I banged in that nail to here, but we're in with what? 1 or 2 centimetres? Yeah, so that's all right. So if we go back to the 20 metre point, which is this point here, and measure to that window. So another type. Who's got a type? Give me an end of your type. Right. So you want to hold it in 20 metres?
Yep.
which is, no, not
20
20 metres.
metres.
Was it 20
you're good
metres?
at this,
Have a look at
That
it.
window.
Which one do we want this point?
No, we're going to measure from there to there, yeah. So,
But how do we know where we stop along
well,
this?
because I've gone along there 20 metres, says to there to that
Oh,
point.
you're to there. You're
But
to the
it's
centre.
over
Yeah,
here,
you're to the
20
centre of the
metres, yeah.
circle. The
Oh,
circular,
right, okay.
the circular window.
So we're going to wait, right?
Has it
What's
gone
this one
across
here?
Yeah, 20. It doesn't.
Oh, no, that one's 15 metres, 15 metres.
Oh, okay.
15 metres up there a bit. Yeah. Right, what should the distance be to the corner of the window?
Are we good?
Yeah, what are you measuring?
7 metres 67.
7 metres 67. So what?
Oh, is it?
Yeah, but she's measured it though. What do you?
762 it says on here. 762.
762. So it's fine, right?
Yeah.
So if then I do it from the other side, so if I go along there 5 metres.
Why do you want to do it on the angle?
Well, this is called trilateration. So I've got a measurement there, 15 metres, and I've got a measurement there, and then I'm going to go back to where we said 5 metres, and measure out again
and then
to the
do
centre.
the other,
And they're fixed.
And then you've got a triangle.
They ain't going to go anywhere, right? So that could move like that, but the dimensions will also always stay the same.
Yeah,
So
okay,
providing
so
that
you're
is
doing the
good,
triangle.
that is good. So you start building it up by measuring all this, right? But you can also measure that by chain and offset, right? So I can stand here and I've got that little optical square, or I can stand on it. I go like that and that, and measure from there to here. But also I can measure from there and move the tape back and forward, and you'll soon see when you're on the right angle, when you're not. And you can do it that way. So that way you're looking at 2 measurements, right? And it's quite accurate. But that way with 3 measurements is more accurate. All right? So it depends on A, the detail you're fixing, and how quickly you want to get through it all. And I would combine both of them, a chain and an offset, or trilateration. All right?
How is that different to triangulation?
Triangulation's angles. So you'll have a baseline, then you go off, angle off of there, internal angle,
Yeah.
and then you can go off any one of their lines because it's fixed with this base and just use angles.
And trilateration?
It's just distances.
It's just
Distance.
distance.
I think I've always called trilateration.
Well, I did up until not very long ago.
Yeah. Okay.
And it was Andrew Wilson said, you need to trilateration. I've seen,
Oh,
all right, been out that is. Oh, yeah. And I've done it all the time and not noticed, right? So it's just a combination of things. But they mapped the whole country, the whole of the UK was mapped by triangulation. So they had one baseline here down south. They went across the Northern Ireland, they went to France, they went up Scotland, and they took all a series of angles from trig pillars, the big white pillars at the top of mountains and hills and that. You've got a benchmark on the side of it, which is a steel plate, which is a good level. And then you've got a plate in the top you put your instrument on, and you can measure an angle, but you need a 1/10 of a second accurate instrument. And you'll take 9 sets of angles on different parts of the circle. So it's quite involved. And you'll have somebody, if you can't see them, you use what's a heliograph. So you'll map the sun to a set of mirrors, and you'll flick it behind the point so he can move his instrument onto it. And I've used that in Africa, in Nigeria. And it's surprising how good you get. But that's a series of angles. And when you get up to Scotland or Northern Ireland, you've got your last set of angles. And then you can check the distance. And hopefully it'll be as good as what we were just checking now. So that's how it was originally done. And that's how they mapped Everest. So instead of doing horizontal angles, they were doing it by vertical angles and stepping your levels up. And they got Everest, I think they did it in early 1700s or something, and got it within a few feet. So it's, but then they probably had 300 or 400 people for the kit and the resources and all the rest of it. But when I was in Africa, I couldn't even hold a booking board because I was sent out with all these guys, and they even held my pencil with me. So I was teaching them how to go about surveying. And I would say, I can do it. I'll lift it. Oh, Buana, you're not meant to do it, you know? All right. Yes, of course I will. But I don't think any of this is going to affect your grades at all. It's just an awareness.
So one other question, sorry. You said to do this, but what if you don't really trust your sort of...
That's why I use the thing on there. So if we go over here then. Yeah, you like that, didn't you?
Yeah.
So this is this right. This is this right angle thing. 40 quid, right? So if you look through this, you can see the tape on one side, the tape on the other side, and if I go and hold the pole over there,
I want to look in the prism.
so move your head up and down, you'll see the tape going that way. Obviously you can get it a bit straighter, but if I go and hold the pole in the corner there,
What are we looking at?
with the bottom one,
What bottom one?
there's a bottom glass, come further back. The glass looks that way, that glass looks that way, and the one in the middle, the yellow, is straight ahead. And what you're trying to do is line it all up. And it's a prism, so it's exactly set up. So you should be able to see this. Yeah? And then if you look at the drawing, so if you access my CAD drawing, when you go along the distance and offset, right?
It's just like a yellow shaded.
Well, it is shaded because you can't see, because of the undergrowth in front of it. But the pole, do you want me to hold the pole up and you have a look at it again?
One of these is there.
Yeah, I've put this thing over in the corner, but because of the undergrowth, you couldn't see it. Now, who was looking through it when I lifted it up?
Not me.
No one. I'll lift it all up. I'll go back and lift it up and you look at it again, right? So you can see the tape going one way, you can see the tape going the other way, and in the middle, you should be able to see that
Do you want me
pole.
to hold it up?
Yeah, go on the other. So just hold it in front of the undergrowth.
Under the undergrowth.
In front of it. And what this does is this is the same idea as going like this, but it's more accurate over longer distances. But I would still, if I was going to measure that corner from here doing this, I would much rather use it by... Yeah, that's stick, yeah.
Oh, I can
Hold
see
it up a
you.
bit. In the corner.
You see your crotch. You want to move out of the way? Are you trying to measure the corner of
It's right in the corner, yeah. No, it's meant to be right just in front of the corner because I'm trying to measure that corner.
Oh, right.
Yeah? So what I'm trying to do is the training offset, right angle,
Yeah.
is me trying to get that with a simple measurement from there.
So you've got to get even closer.
Yeah. That's what I do.
In there.
Yeah, if you can, that'd be
Okay,
smashing.
cool. Swapsies.
Yeah. Swapsies. But they might, because they've got to move their heads up and down. No. So if you come back a little bit, and then move your head up and down, you should see the tape go on both sides. Yeah? Now that should line up with very, very closely what the tape's going either side. But you find out you see it if you come further back a little bit.
And knowing where your boundaries are.
And then move your head up and down. Yeah? They should all line up.
Yeah.
Alright? So that's using an optical square to give you a right angle. So you could measure along here at the distance stated out to that corner of that building fixed. But I could also check it by triangulation, trilateration, from there to there and there to there.
Right.
And that's going to hold it together solid.
Yeah.
Alright?
Meaning I'm measuring the distances of the three
Yes.
sides and then computing the angle.
Yeah, because I've got it on there, because I've come along. Is it
Yeah,
12.35 or 38? I can't
Yes,
the 2
yes.
or whatever it is. So I'm going along there, then I'm taking a right angle into that corner.
Yes.
It's quite a long distance.
Yes.
So there's an element of risk on making it swing because you can't get exactly 90 degrees. Even with that, because I don't know if you look through it, there's a little bit of difference between the types and that and there. So I wouldn't rely on that. I would take the dimension from there to there and there to there if I can, or do it from this baseline and get in there. It's more accurate. But what I'm trying to tell is the principle, you can use that to give you stuff that's away and know it's exactly right angles. Yeah?
Can I see?
Can you see it? Move your head up and down a bit. See that one? And that's the top. The bottom one, can you see it?
No, I can see someone's jacket.
That's probably that jacket.
Yeah.
So if you ask her, move back a bit.
I get it though. I get it. So it's like a continuous line.
So you get 3 of them all line up.
Yeah. Okay. That's
All right.
good. Yeah. I'm going to have a second. I thought
Yeah.
a yellow.
And obviously the longer it goes, I mean, if you've got short distances, it's much harder at savouring, but so you've got to move back and forward and front and back to get it online. And what I've done is I've taken it from the computer, so I've taken a point between there and there, and I've said come from that point, right angles, perpendicular, what is the distance, and then make sure that is, I can see it, and is it 90 degrees? Because if it's 90 degrees at that distance, it means that I've surveyed that in the right place, basically.
Oh, I see.
So it's about making sure that that's in the right place rather than this.
This is what we're doing, we're interrogating my survey.
Got it.
All right? So
So
that
if that's in the right place,
well, you've got an overall measurement. I don't know if you remember I was talking about the manhole. I've taken the centre of the manhole, but it's not ideal because it's not a fixed point, because it's around that. So I've got the distance to there, and I think it was within a centimetre. So I'm happy with it. All right?
okay.
So we haven't found any problems yet.
What you are saying that if we can't see Jonathan through this is not 90 degree.
Well, if I go to Jonathan and move the pole to one side, it won't line up with this tape.
I see.
So then the whole thing would need to move forward and back along a line, so it is 90 degrees.
Okay.
Yeah?
Yeah.
So if you wanted to fix a tree on there, you would move back, up, forward on that line to the tree lines up with the tape going there and there. So you see the tree in the middle, and you'd have the tape in the top and the bottom. And when you've got that, that is exactly 90 degrees. All right?
Would you set up this line and then you do a few things off this line finding 90 degrees?
I'm sure I wouldn't survey that building from doing this because it's too risky. Because you're talking about centimetres. I want it better than that.
Yeah. But for a tree, this line.
They'd be fine for a tree or the edge of a flower bed or a garden shed, because it doesn't matter if the garden shed's a bit out.
Yeah, but you can't have the bit right out front.
No,
of the door
because there might be a pond in the way. There might be a pond in the way, right? And you can't physically go across there with a measurement.
I have a question.
Go on.
So we studied that the baseline should always be a fixed point that
From a
cannot be
fixed
moved.
point, yeah, ideally. But it can be anything. I could come off that corner of that wall there to the corner of the building. They're fixed, not going to move.
Okay, yeah. So that I would agree with. But what you've just taken it from
A
the
nail.
middle of a nail to.
Yeah, but I've
is there a
surveyed these nails. These nails are on the scan data. I've surveyed them with a total station, and I've surveyed it through trilateration and through baselines.
But if we didn't have nails and we were doing this on a site, we would want to go to like a fixed point that cannot be moved, right?
Yes,
Like a
but you also
corner
want a
of house.
point that is not going to be affected by your design, that you're going to put hoarding round it. You can't get that corner or something else. So you're either going to bang in wooden pegs with a nail on top of it,
Okay, fine.
and that'll be a survey station or a baseline station. So you want something that you can keep coming back to.
Got it.
But it needs to be outside. But then again, you would have other baselines working towards your site that you're working on, because you don't want big long distances away. All right, fine there now. Sorry.
We're just having a private moment.
Mike, I want to just have another quick look.
Yeah, you might as well. Yeah.
Might lose it now, otherwise.
He doesn't know that the video's on. If he's been, being naughty.
Cursing and swearing, yeah. But the idea is I would use this when I thought it was necessary. I would much rather do it with chain and offset, so I'm measuring a physical tape, going back and forward to make sure it's, because again, if you have got something there, if it's there, it's not 90 degrees. If it's there, it's not 90. If it's there, it will be 90 degrees.
Yeah.
Yeah? So it's easier to measure stuff like the other way around. Yeah, good idea, thank you. So you can swing back and forward to get it. But again, if you're unsure about that, or you think there might be a source of error, the trilateration's the most solid one. All right?
Okay.
So in doubt, use trilateration, because if you've got three sides of a triangle, it's not going to change unless you read the data wrong. You read the level wrong, the type wrong. All right.
So David,
So interestingly, if I, as I've never done it before, I would just put it off the building. But you've not done it deliberately, not done it off the building. Is that because the building's got this?
Well,
weird
think
shape?
about it. Yes.
So you can't get a good line.
All you
off
can
the
do is
building.
you can pull a baseline in front of the doors.
Yeah.
Then the brickwork steps in.
Yeah.
So if we go along there and have a look at it.
It's not actually going to be a useful marker.
Well, for me to line up the edge of that,
Yeah,
it's probably almost to here,
Yeah.
right? Which is good, because if that lines up to that, I know that's in a straight line.
Okay, yeah.
So my baseline could go from there to there. The trouble is I can't measure this stuff from that baseline.
Good start point. Yeah.
All right?
Yeah.
So the way you would get round that, assuming that that face is the same as that over there, again, you're not sure because we've just said it's finishing there. So you've got that distance, right, to contend with. Now that might be the same. No, it's not. But the best way would be to come off 2 meters, banging a nail, a healthy nail or something.
Yeah.
Come off 2 meters on there, banging it,
Just do 2 meters, 2 meters.
whatever, and then just come along your chain line, measure off to everything, 90 degrees. And then you need to check that against something else. Line up the edge of that. It's probably almost to here, right? Which is good, because if that lines up to that, I know that's in a straight line.
Okay, yeah.
So my baseline could go from there to there. The trouble is I can't measure this stuff from that baseline.
Good start point. Yeah.
All right? So the way you would get round that, assuming that that face is the same as that over there, again, you're not sure because we've just said it's finishing there. So you've got that distance, right, to contend with. Now that might be the same. No, it's not. But the best way would be to come off 2 meters, banging a nail, a healthy nail or something.
Yeah.
Come off 2 meters on there, banging it,
Just do 2 meters, 2 meters.
whatever, and then just come along your chain line, measure off to everything, 90 degrees. And then you need to check that against something else, and you need to check that bit against something else. And then you build it up, you've got that fixed hard. You've got a baseline here, you can then measure all the paths and openings and everything from either that or that. And so you're starting to build up your drawing, right? And then you want to say, how do I get that corner over there? Because it's quite far away.
And it's curvy.
I'm here.
Yeah, so what you could do is line up this against make a corner or the end of the buttress where it meets the hedge. Now if I go back onto the wall, I can line up that with that, so I know exactly where I am, and then I can measure into the corner of the wall. And that's fixed it, because all I do is just draw a line through that, measure from there to there, I've got that corner fixed. And it's fixed quite well. And then you would check it, because you could have an overall measurement along there to confirm it, and then take a corner from there to there, back to trilateration. So you're starting to build up these triangles everywhere. And it doesn't matter if it's chain and offset or whatever you do, right angles, you're starting to get confidence in what you're doing. And when you start to draw it all up, things should work. And what's called as redundancy is you can get rid of your chain and offset or your trilateration because everything else fits. So then you get more confidence building.
But then if it doesn't all fit, then you
Well,
have to
one
go
of them's
back and
wrong.
look again.
Yeah, but you're only going to have one or two.
What's there?
Well, again, within its plot scale, if you're plotting at 1 to 100 scale, and as I said, 10 mil, 20 mil's not going to matter.
You just average it out.
You know, again, you've got to look at the importance of it all. So that's the idea on this type of stuff. So we've got a whole bunch of measurements on these sheets where I've taken, you know, we've got this corner here done, we've got 1 or 2 round there, and then I've taken from there. You know, so we could take all these and hopefully they'll all be good. And so far we've been all right within a centimetre or so, which is, as I say, thank goodness. But that is the idea. So it's a case of just building that up. And this survey's out of date, as I said to somebody, because that little tree that I surveyed is no longer there. So again, whatever happens is the survey's going to be correct at the time that it was surveyed. So if it's left for a year and you're on to other jobs and your client is trying to get the budget together and he comes back a year later and your neighbour's changed it all, you can't go back to the survey company and say, this is what changed, you need to survey it all, because he's going to have to ask for more money. You're going to have to either survey it in yourself or say to your client, that's changed. I need to know where that new wall is or that new building because it's going to affect my design in one way or the other. So that's how you approach
I guess
it.
also then we should maybe be warning clients, oh well, if you're going to wait a year now,
No.
just be wary that we might need a new survey.
Well, you could say that out of passing, but I wouldn't make it a crutch point to get them to spend the money. Because some people quite like the idea of it, but when you come and tell them how much your time is, how much the plants are going to cost, how much time it is to design it, then that's going to go through iteration. They're going to say, blimey, it's going to cost me 150k. Maybe not. I was expecting 20. And they say, well, 20, I can give you half a dozen plants and a little sketch. No, I don't know, but you know, that's the idea of it. So that's it. So are you getting the drift of it all? Yeah?
But I think, so like with the manhole covers, for example, we might want to know where they are, but they don't have
Connections.
measurements. So how do we
Measurements?
know? Oh, sorry, connections. if that's the
Connections,
right
yeah.
word.
So I haven't
know
lift.
where
I
they
mean, I could lift that now, right? I could get dirty fingers and lift that.
Yeah.
And that's probably going to be a foul sewer going that way or coming this way.
Okay.
And I haven't got any keys, but we could have a wee look at it.
Get it open.
Come on, David.
Come on.
Right, so that is...
How many flushes do we need to
Oh,
get?
yes.
Now, that isn't... It's wet, but it's not moving, right? It doesn't smell too iffy, so it's probably surface water.
Yeah, that looks all right.
Right? But it is a wee bit smelly, but you got 150mm pipe coming from there, which might come from that manhole, and you've got another one coming that way, right? So you would dip that from the cover level, and you would also, yeah. So that's what I'm saying. If you get that's probably 2.2, 2.3 meters deep.
Right.
So if you're digging 200 a sunken garden at 2 meters, you've got a problem because you're getting very close to the top of the construction. All right? Yeah?
But you get a free trill.
A free. Right? So I haven't got keys to open that one. I'll go and wash my hands in a minute.
Pipe that was coming in.
Possibly, but that would be a backdrop. And once you start getting into drainage, it's a whole different ballgame. So that might be what's called an external backdrop. And what it is the drainage comes along about that below the ground, and then there's a contraption where there should be a cleaning iron. It'll come down and curve round and come out the bottom of that.
Okay, so this is higher up in the ground. And then...
Possibly, but it's unusual that it's on line, and it'd be silly to have two sets of drainage. Because sometimes I've seen it where that pipe is high and it'll actually come through the middle of the chamber.
Oh, okay.
And that's just odd. That's bad design. Because how do you maintain that? How do you get people down to clean it out or whatever? So I think that's a backdrop. All right. So again, that pipe's going that way. You could mark it off with the survey arrows or whatever, and then you make sure that you keep clearance of that because you don't want to destroy it. Because you know, the person away down there, if it gets blocked up, they're going to be knocking on somebody's door. Yeah?
David, do you know if there's a standardised practice of building your manhole cover in a certain line with the...
Relative to the pipe. Some of the people that construct manholes think about that, other people don't.
Okay.
Because you might get them in at different. But generally, as I said, when I looked at that, I thought the pipe was going that way.
Yeah.
All right, because again, that's from my experience.
So
it goes a long way.
Going that way.
No,
It's going this way.
Oh,
But that one, if it's what I think it is an external backdrop, it is coming that way because there's another big pipe down there.
Yeah.
And getting pipe sizes is quite critical as well, because that one at the bottom looked 150mm. 100mm can take so much water, or whatever you want to call it.
Just water.
It can take other things.
Sometimes.
So 150 is bigger and will take more. But when you go up to 225 and 300, that's very hard because they're generally deeper, and you can't really guesstimate what size the pipe is. So there's other ways of going it. And if you go down that, because that's probably a limit, you're putting yourself at risk, because if there's methane gas down there, you'll be there for 2 minutes and you flip and pass out. And the trouble is that somebody will go down and get you, and they might die. So it can be quite, which is why we've stopped doing. Yeah. Right?
Why would it be
Yeah. So get another company to do that's a professional company to do it. Survey. I used to do it, and I would dip that, and I would then find out with the next manholes, survey the top of it, lift it, dip it, and then say there's a gradient from there to there, and that's it, and it's the size as 150 pipe and it goes that way to out in the road. And they used to think that was great. But as time goes on, people say, no, I can't do that, it's too scary.
So in this instance, would we want to get, like, if there was these kind of services here, would we want to do an underground survey or get somebody to do an underground?
If it was critical to your
Like,
design.
If we wanted to, like, dig something there, that's probably not going to be feasible, is it?
Well, it is, providing you only go down that much.
Yeah.
Because you still need a fair amount of cover. But again, the contractor who came round, so if you design something here and your contractor come round, he should lift up the cover to find out what's going on and the depth of it and where these ones are going, because he doesn't want to destroy it or damage that in any way, because it's not his responsibility or your responsibility.
Yeah.
But if he's got any sense, he will then say, your design round here, can we not move it that way or this way? So we avoid that. And then,
saying that if you put something heavy on there, does that?
well, that's probably, it's cast iron. So you wouldn't use that type of cover in a car park or something, because you got a big truck going on top of that, it'll crack it, all right? So there's special manholes for special locations. And some of them are concreted in, some of them are like that, some of them are heavy duty, and some of them are bloody heavy, really heavy. And I couldn't lift them on my own. I've done it and nearly done my back in, but they really weigh a ton. And when you're in the middle of the road and you lift it and you think, I'm stuck, and there's cars coming back and forward, it's a bit scary.
It's a dangerous hobby.
Yeah, so again, get a professional company in to do it, if it is critical. But by and by, as long as they put it down there, they can put it as an inspection cover, they can put it as a manhole, because again, you don't know what it is until you lift it. That is classified as a manhole because it's over a certain depth, and somebody can go down to investigate it. Well, if it was short, it could be classified as an inspection cover, because what you're doing is lifting it and inspecting it, and if you need to clean it out. And if it has pipes or valves or things in it, that's an inspection cover. Manholes are generally only given to file and surface over a greater depth. All right. But again, you know, in the video I called it different names because you just get used to it. It's a bit like triangulation and trilateration. You just get used to saying something, you don't think about it too much. All right, any other questions on any of it?
So is that called chain and offset? Did you say?
No, this was me pulling down, I don't know if you remember, but I've got a station up there, a survey station, right? Which I know the exact point of, and I know the exact point of this one here. Why I then decided to go to the centre of the manhole, I don't know. Probably because I didn't want a clash of lots of lines on here. So when I pulled this, I got 23.52, and I don't know what it says on your drawing, but it was about right.
23.54.
Whoa.
5 for 2 centimetres, all right? Yeah. So I'm estimating the centre. I don't know how well it is. I could lose 5 mil or something at that end, so it's okay. It's in the right place. And as I said to you, I've got to chop away the edges to get the true corners of it to survey it in its correct position. Otherwise, it's relative to where because I'll say that's a 470 manhole by 570 or something, and it depends where I take my survey points, depends what the computer draws, and then arriving at a centre point. Yeah. So I've arrived at a centre point from the symbol that was on the computer and said this is the distance, and it's within 2 centimetres, so that's fine. Yeah. Because it's not going to matter. Because if it was critical, you need to know where the pipe was more accurately, certainly if you were digging up there or digging down there. But again, to be safe, you would have an easement, so you'd say I can't build within 3 metres either side of that because it's too dangerous. Because if it changes direction, there should be a manhole on it, but they might not have put a manhole, or it might be buried. So if it comes down here and there's a dog leg and you don't know it's there, the way around that again is to bring in a professional underground company, and they'll send up a CCTV camera, and they'll obviously check the cover level to pipe, but they'll also tell you the distance from there to that angle. And then you can investigate it, see if there is a manhole there. And if there is, then you need to survey it in. So there's all these other things going on.
It looks so ugly in the middle of the lawn though. Could you not also get that moved?
Well, there is a set distance generally between manholes. And as I said before, they might be combined. So the down pipe, it might be an internal down pipe off a roof. There's no other evidence of downpipes, right? Mm-hmm. So if the water runs off the roof...
Well, it's on the other end. So.
Yeah, but there was another pipe coming this way, I thought. I'm not sure, I need to lift it again to find out. But it might be a combined route. So if you get lines of sewers coming that way, and something coming that way, and something coming that way. In the construction, that's hard to change because you need to put another one there to move it that way.
Yeah.
So
That's what I would suggest. I would have suggested them to be moved to the path.
but again, it's got to be far enough away from the foundations and everything. So if you get subsidence in the house, you don't want subsidence in your drains. So it starts to, you get starting thinking about lots and lots of other things. So if you find drains and services and they're in the way, for you to get round to get them shifted could be another expense, quite a big expense. And that needs to be weighing up the design of what your client wants. Because you then say to them, actually, you've got gas, you've got electricity, you've got cable TV, you've got big manholes. We could put covers on them that you can get access to them after, but it is going to change the outlook because you need to put access chambers or something to it. So it's not going to work. And then they might say, well, move it. But again, to get somebody to move that could cost you thousands and thousands and thousands.
Design around them, so let's say build something over it.
Well, a lot of people, a lot of people have got them in their kitchens, right? And they've got a tiled floor, and you can see in the tiled floor where there's evidence that now that shouldn't be allowed because
industrial kitchens have it allowed.
Industrial kitchens are fine, but not domestic. But even an industrial kitchen, because where that, I keep going that way for the pipe. That way for the pipe, if I've got a building there, the foundations need to clear the pipe, have no influence on it at all, so they need to bridge it with a lintel or something, and there needs to be clearance for the pipe. So that manhole should never be in a building, it should be outside the building, which is what you're saying, and the connections will run to that, because it's not a good plan. Because if anything happens to the building either side, the service is destroyed, and they can't access it, they've got to rip out the floor to get access to it. And I had one in my first house that I had, and it was in the kitchen, and I got them to dig it out, cut back the pipes and re-establish what you were saying, the new manhole outside. But then I was doing an extension with a new kitchen, so I was able then to take the pipes to there as opposed to going to there. But then the council said you need to support this, you can't have it running through the building. So you get round it, so where we thought of our services were just a name that becomes that it could cause you problems.
Yeah, to that point actually, I was thinking, could we plant around it? Is there any sort
Yes,
of
you can.
requirements on? So if you wanted to hide this, if it was in the middle of a bed,
Yeah.
and you couldn't see it,
Fine.
plants, is that allowed?
Well, it is. Again, it depends on depth, because if in a drought like we've had this summer, and you've got a moisture-hungry plant like a poplar tree, and the roots go down, and it finds a crack, a hairline crack in the salt glazed pipe, the clay pipe, you'd be surprised how much damage that does. And it can cover the whole lot of it, and then
Rockery, rockery on top.
so planting near manholes is all right for flowers and biennials, whatever it is, but anything substantial like a tree. So I wouldn't do it, but you can put plant pots on them, that's fine, as long as you can lift them off if somebody wants to clean it or look at it. So yeah, you can hide it, you can put a wooden cover over it, you know, you can do it, as long as you can get, or somebody needs to get access to it, they can. Yeah? And as we were talking about the levels, contours and all that, and we were saying in that corner, wasn't it, the contours were going up 300 mil? Does it look 300 mil? It's probably ish about that much. Ish, probably, without checking it. So again, my levels and my contours probably look all right.
Do you measure those?
Well, it's from the levels, so all the levels on here, these are my level points in blue. And then somebody was talking about the camber on the pathway, where the contour runs up there to the top of the camber and then runs down the other side. So the contours are based on the levels, and the levels need to be correct to the datum. And as I said, you've got a plinth line on here, as I was saying. So there's your plinth line, right? On there. And there's your DPC, which probably in this case is slate. It's broken away, but it's under there. So if you can't get access to the floor level, and you think that is a good datum, you'll be able to chase that around the whole building. You'll still end up with the same level. So everything's related to it.
Yeah, I was just saying what you related to, the building.
Yeah, if you want it, yeah.
Sorry, you're talking about damp proof level?
Yes, the top of the plinth is the DPC, which is probably just under there, which is almost floor level. So again, you're only talking about a centimetre or so different, maybe even less. So that is a good datum to use, providing you can continually have access to it when you do that. Failing that, I would bang in a steel pin or a peg away in the corner, based on that level that you can always go back to. And nobody's going to destroy it. Well, apart from the gardeners might go up there, what's this, throw it away.
How did you measure the contours though? Was that just a field and survey?
No, they were measured with my total station.
Okay.
All right, so I did it conventionally. So there's one of the slides. I'll send you it because I've got to check that Marco's got all the folders and all the stuff that you need, the handouts. And within that, I'll show you what a prism and a handset looks like. And that's what I would use. There's a glass prism, 360, the infrared beam comes into it and goes back to the instrument, measures the distance. It's constantly measuring the horizontal angle and the vertical angle. And I can go about here and say, give me a level there, Bush, give me a level there, Bush. And when I process it in the office, I've got my levels there. Right? And then from that, I triangulate it, and from that, then I can get my contours.
And maybe really stupid question, that's 5.35, etc. that's on there, that is 5.35 metres above sea level.
Yes.
Yes, that's
Newlyn. Yeah, Newlyn. It was all based in Newlyn down in Cornwall.
Right, okay.
And what they did is over a period of 5 or 10 years, they measured the high level tide and the low tide, and the high tide and the low tide, and got a mean. And that then was used at the whole of the country. There was a Liverpool datum at one time, but everything's now based on Newlyn. And the GPS used what's called a geoid, which is a mean going through levels and seas, and so it's a nice globe. Well, it's not a globe, it's bloody elongated, isn't it? And that is based on a mean sea level of the world, and you can work out the difference between Newlyn to these levels, or to the GPS levels. But the GPS, I told it where I was, and I've got calculations that then give me it, that when I checked these levels, my station levels, with the GPS, it was within 5 or 10 mil. Right? And that's from a bunch, it was brilliant.
Within your tolerance.
Oh yeah, but it's amazing, from bits of metal up in the sky.
That is amazing.
Yeah,
It is amazing.
Well, what is the difference between the grey numbers and the blue numbers? I realise they're kind of they're, like, for instance, the same there.
Yeah. So they're going that way. So that's contour levels going up the hill, and that grey line is a contour line that traces between the level values.
Yeah. Oh right. Okay. So sorry, but so you've got plus 5.39 there.
Yeah.
You've got. Sorry, that one's not a good example. This one plus 5.35. So is that just, that's the contour line there, and we're going uphill. So
yes, that's
5.35, and you're actually
gone up.
Gone up
4 centimetres.
0.04 to that point. Okay.
That's it, yeah.
But have you gone and stood in those places where the blue is?
Yes, with my pole.
That is why they're in those kind of random.
And this is what I'm saying about, this is a 1-to-100 survey. That's got quite a good coverage over that area, because you count them, 2, 4, 6, 8, 10. There's 20 or 30 levels in there. You don't want a survey company to give you one in the middle. It's no good to man a beast. So I think this coverage at this scale is fine. I could have put millions more levels on it. The contours would then have traced that a little bit better, but not a lot different to what I've got, because I'm looking at it when I go round.
How do you choose the specific places to stand? Do you just kind of that's a bit lower, that's a bit higher?
Well, you need to do the edges. You know, so you'd do the edge of the tarmac and then the grass, and then go in 5 metres, take a shot, go in 5 metres, take a shot, and then you're probably almost at the other end. So you take one in the grass and one in the soil. So you're just going everywhere. Yeah, and like a grid.
Oh, great.
Yeah?
Are they the total stations, the things you said costs about 30 grand? Yeah. And you just use one and just put it.
Well, I put it on each of these points. And so I survey all this stuff from there, but I've put a point in there, and this is my get out of trouble, because what I've done is, if I need to set up, if I lose that one, I can set up there and re-establish that.
It's like your save.
But you just use one
saved file.
One instrument, and I move it to different places and check the distances and the angles between the other points. So I'm constantly checking where I am and what I'm doing. But then I get connections by exactly like trilateration with everything. So regardless of where the stations are, I can take distances from there to there, and fix a really tight shape. And then I've got it fixed that way as well. And then everything that I measure from that is as good as, you know, so I'm trying to, in the notes it says work from the outside to the inside. So as long as I've got a scheme on the outside and then measure to points in the inside and then create baselines on the inside, my accuracy won't get any worse. Whereas if you start the inside with a small baseline, create baselines outside, you may be introducing errors because in the physical measurement of it. So by the time you get to the outside, you've been losing 30, 40, 50 mil. So you always start from the outside to the inside.
Okay.
Sorry?
Where are the boundary measurements like on here? Which ones are they?
I've not taken any boundary measurements.
Okay.
All right, what I've done is, this is cut off, but there is a wall up there if you see in the big plan. That's the edge of the foliage, and the dash line is the edge of the grass.
So that's, but
then I've got the wall there.
Okay.
Yeah.
So we have to work out the measurements by either just coming back and measuring it, or
Yeah.
from what you've done to scale and then working out.
But if we were to, based on what Harry said to us, I feel like if we were to import this into SketchUp,
It just does it for
it
you.
would automatically come up with the correct size.
Right.
Then,
And we
I
check
believe.
it.
Well, as long as it comes in with scale.
Yeah.
So
Yeah.
you've got this.
And does it say what scale this is? I guess
It's
it does on the
1 to
bigger.
100.
Yeah. Okay.
Yeah. So you can, once you get it, you can take a measurement in your CAD system from that corner of or that station there, which you just drive a little nail, to the centre of that manhole, and it should come out at 23.54. If it is, the
And so it's
scale's all
already on
right.
your, like, ground
So you
plan.
can check it in physically on the scale, but you can also check it in a computer.
You know when Harry downloaded from geolocation?
Yeah.
I feel like in theory I'm thinking this should be the same kind of thing then.
It should be, yeah. In
If
theory.
it works
Right.
perfectly.
And as I say, the only thing I've got to do is finish off putting 3D contours on it. So if you start to look at it, interrogating 3D for cross sections,
Oh, the plan.
you don't have to
Yeah,
work
yeah,
out
yeah,
things so
yeah,
much.
Yeah.
He covered, did he?
No, he didn't, but you can't.
But maybe
It
it's
was
the
just,
same, like import.
That's what I'd be trying to do, yeah.
Yeah.
Right, we'll all
Alright.
be asking that question of Harry when you
Yeah.
do that then, yeah.
So would this be a day's, like to do the whole survey if someone's getting you to do it? Would this be a day?
I did this in a day, yeah.
A day, yeah.
And then how much time at the office afterwards?
It's probably a day and a half or something to draw it all up. Because you've got to go through and tidy it up, you've got to offset and put the levels on it and rotate the levels, run the model, put the contours in, trim up the contours, put splines through them. So there's a little bit of work, but also what I was doing then was checking it to other, you know, my other things I did.
So it's
So it's
2.5 days.
You know, it'll be 1 day's charge as far as we are as a company.
Oh, okay.
Yeah.
But, it's
But that's
like
what I'm saying, so if you got-
actually more like 2.5 days worth of real time.
Yes, so if you go to another survey company and they charge you 400 quid, you think, oh, bargain.
But then they might
But then
add
they
on-
say we're going to have office time of a day and a half,
Yeah.
and our office time is 300 quid, so that's 400 quid onto
you're
your
like fixed price,
400s, you're
800.
850.
Yeah.
Okay.
But you need to ask them that. You need to say, what do you charge a day, and what do I get for that day? What are you going to give me? If I want 100 survey of a back garden, can you do it for that? And if they say yes or no or whatever, then you get into the discussion. What does that entail? Are you going to come to site, do the work, whether it takes 1 day and you got a rainstorm and thunderstorm and it runs into a second day, you're only going to charge me a day, it's not my problem. And then whatever office work, you come up with the drawings or the digital data, and that's within that charge. All right?
Okay.
But companies do charge different things,
Yeah.
different ways.
Yeah, that's very useful. Thank you very much.
All right.
I did take them.
So it's all a bit clearer than it was this morning.
Yeah.
Yeah.
I have a couple of other questions about the colours on the plan. So your green lines, you've got red lines, you've got yellow lines.
Right, the green lines and the red lines and the yellow lines are purely constructive stuff for me to try and take out dimensions so that I could look,
So that you're own.
so that you guys could interrogate the
It's
survey.
your code. Fine.
So if you look at the
some people
drawings
do it
in
all
there,
black.
sorry, yeah, if you look at the drawings in there, I've got all these lines on here, which I used to print off this for us to do a little bit of work on it.
Yeah.
But if you look at the other drawings, they've not got anything on it. It's just a
Okay.
clean survey.
Yeah, fine. And then similarly, you've got different coloured numbers. Is that the same? It's
Well,
following the same-
I've put my stations in orange,
Yeah,
but all services usually go in blue. And then you'd have
Right.
other
Yeah.
text in black, descriptive text.
What's these small little services?
That says water meter, does it?
WM,
okay, cool.
yeah.
Water meter.
And then what's
And then
that?
it's SC, stopcock.
Stopcock.
SV?
SV, stop valve, possibly. Again, stopcocks and stop valves. What are they?
Stop the water.
I think I need to write this.
Yeah, but why is it called a valve and a cock?
What's the difference?
Well, that's not going to come on. Is it?
It's gone.
I think one's on the mains and one's is to individual property.
Is that the root? So the cock is for the
Individual
individual.
property. And a stop
Lucky individual.
valve. A stop valve is quite major, I think. That's what I think.
Stop.
And then you,
IC and CL.
yeah, you said
IC is inspection cover.
okay.
And what was the other one?
CL.
CL, soffit level.
Champions League.
Soffit level.
Yeah. Oh, CL, sorry, CL. I'm thinking S. CL's cover level.
Cover level.
And where I would have measured from the cover level to the bottom of that pipe, the centre of the pipe, that would have been an invert depth, ID.
Oh, so you're saying there's a manhole, there's
I
a
see.
inspection cover, and then to the bottom of the inspection cover.
No,
is
no,
5'3"?
no, that's the top of it. That's to the lid. The lid. The bit I lifted up,
Yeah.
that is what that level relates to.
Yeah.
Yeah.
I think we're saying the same thing.
So we're not measured down into the pipe. We haven't got that.
Okay. And GY?
GY gully.
Gully.
What is the gully?
A gully. Let's look at a gully. Where's the gully? There's one over there. Let's go and have a look at a gully.
Drain area.
Yeah.
It reminds me of like in the Netherlands, like a little round between houses there's a gully.
Well, you,
I might used to call it anyway.
yeah, but you can
Different to the
get
one in the
box
ground.
gutters.
Is this a gully?
Yes, and that's a gully there.
Oh.
A gully. Let's look at a gully. Where's the gully? There's one over there. Let's go and have a look at a gully.
Drain area.
Yeah.
It reminds me of like in the Netherlands, like a little round between houses there's a gully.
Well, you,
I might used to call it anyway.
yeah, but you can
Different to the one in
get
the
box
ground. Is
gutters.
this a gully?
Yes, and that's a gully there.
Oh, got it.
But you can also have box gutters. So, they're long ones, metal ones, at the bottom of the driveway or everything.
Yeah.
Is that not a drain? What's the difference between a drain and a gully then?
Well, the gully, it rains, so it's going to go down there. It might go to one of their manholes. But I would think that it's going to go to that one, possibly, or connect somewhere, and it might go to a soakaway. But I don't know, as I said, I've not investigated the drainage round here. But it's strange you get two covers there close to each other. As I said, if you're getting two covers close to each other, generally one is foul water and one of them's surface water. And that's why I thought, wait a minute, it looks as if there's another pipe coming, it's online. If it was at high level, you would have a pipe coming through the chamber that I lifted, but there isn't, so is it an external backdrop? And that is to change the level, because you can't have it too steep, because again, if it's too steep, one thing moves quicker than the other and you get stuff left behind. So therefore you've got to stick to this gradient, and if you want to drop down really quick, you've got to come and have a backdrop to take it down and do it, and then the ability to clean it out if it gets clogged. And that's what a backdrop does. But I wonder what it might be from that building over there. So it might be foul, or it might be a connection for here which is combined, so you're taking the surface water and going down it. I don't know, I'd need to investigate more.
But would you have a gully with an open drain cover on a foul water?
No.
Yeah, I was like, surely that doesn't seem very good.
No.
So these are definitely surface water.
But I have seen in London a small cover with grates round it, and they were known as lamp holes, where in the old days they used to send down a lamp to check the condition of the gullies. So sometimes in an open space in the middle of London you might have them to vent, because you don't want pressure to build up. But you certainly don't want to sew a cigarette and throw it down.
Oh, there'd be an
And also
explosion.
at a wedding venue, you don't really want to be like, that aroma.
No. So but again, saying that, sometimes surface water manholes can smell worse than foul water manhole. When you get the compost all rotten
Yeah,
down,
true,
the leaves
true,
caught
true.
down.
We need to think of some like diffuser situation.
All right.
But this place is rigged with manholes and covers and gullies and what? Just.
All right, what's happening?
And so would we assume that this line, because we saw it go this way, would kind of come this way?
What line was that?
So this was like from the manhole, we saw it.
Oh, yeah,
going that
yeah.
way. So we kind of assume it roughly ran, or it might not. So
There's no more manholes over there, is there?
might turn, yeah, that's why I'm suddenly worried about
No, there's a
that.
cover level there.
Oh, so it probably goes.
Let's go and have a look at that cover level. So we said it was going. It's generally a screwed down. Generally means that it's something that people don't want to get access easily to. You know, whereas that one I picked up quite easy. The other one you needed to use manual keys. This one, it would normally have 4 bolts and it's bolted down. And that's all the different ball game. It'll take them longer to lift it. So it could be that it's part of a major trunk sewer, which might connect to that one up there, as you thought. But again, I can't lift it because I'd need some gear, a jemmy to get under it to get it up. And it might be a connection, but you know, there's quite a lot of trees and all that, right? I can't see the point of it, so I don't know. It could be another service. As I say, these ones, we know that's the stop tap because it says it on it, and I've put it down as water meter, didn't I?
Yeah, water meter. We've got
An error, yes. But that's only, as you said, on the abbreviated description.
But we do have SC here, 533, but it's not near this square. Oh, this little
It's
square.
that one.
That's the stop tap.
But there's another one, is there?
No, you should have 1, 2, 3 covers.
Yeah, 1, 2, 3, and then a little teeny weeny
Or a little teeny one.
Another one. Teeny tiny.
I like it. There it is.
Okay,
That's what you had called SC.
Got it? So that got me over the description error.
Yeah, water meter, we'll be okay with that.
All right, okay.
Because like, that says water on it and that doesn't.
Yeah, right, so that was hidden. We couldn't see that, right? It's lovely.
So nice,
Yeah.
lovely.
That was me scraping away that.
When you come across a site that's basically got multiple drains and sewers and things, but you've got a client that says, I want to change everything. It's basically, you can change it, but it's just a monumental cost involved. Or
It'd
would
be
you
un-
actually
it'd be-
advise them strongly?
It'd be very unusual for to have all this stuff in the back
Yeah,
garden.
no.
First point.
Yeah, feels like a
Second
lot.
point is you may have major trunk sewers going through it.
Which there's nothing
And
to do
that is
about
stuff,
that.
if you can't see it, you need to find out from either the water authorities, as said, or some other way, looking in somebody's garden and see is there any matter. But if they're covered up, you're not going to see them. And again, this is historical information.
Doodads that come out, I don't know about water, but for electricity that you go along the
Oh,
floor,
yeah.
you can,
Yeah.
like,
Yeah,
you know,
electro
on the
detection
pavement
type thing.
Yeah.
Yeah. So you can find it, but you want to ask the neighbour, have a look at where their drains go from the house, and you know there's a gully there and there's a gully there. I can't see any manholes. So is it going to go that way? It's not going to go around the corner of the house, so it's got to be in that side of things. So then you can start investigating. So my only problem I would say to your client is if they've got a major sewer going through it, then that would restrict you on
Yes,
doing
there's
big
only so much
excavation.
you can
So it'd be
do.
fine apart from that. And if they've got no manholes on there, you've not got a problem trying to hide them because you will never see them because they're next door.
Yeah.
So, you know, you're never going to get this
Depends.
scenario.
Yeah, no.
But
Oh,
if
very
you're doing,
unlikely.
like, commercial wedding venues, then you might
Yes. Yeah.
in Kew Gardens.
Yeah. Oh, and there is a down pipe. I saw my first down pipe on the corner there.
Which does come, looks like it comes off a roof.
Well, it is off the roof, yeah, so it's a down pipe. So that's coming to there. So we could look to see if there's another manhole in that vicinity. Well, there is one in the middle of the road, look. So does that run, is it not this one that's running there, is it that one that's running there? So therefore it's surface water. Yeah?
Yeah, if not, I would move it out of the property on the other side.
Yeah, lift it up, there we are, Borowski.
Right here. Bring the wall over.
But if that's online for that, that's because there's probably another one over there. No, that's vented. So that's a foul. See, it's open at the top.
Yeah.
So that's a vented. So that's from a foul
Yeah, I know,
manhole
yeah.
because that lets the smells away.
Yeah.
You can search about lots of information. You go to local water authority and ask them. But if it's private, then you're going to have to look at the owner and just see if you get any idea on all this.
When you say private, do you mean just
Your client. Your client. No, your client, if he's got any knowledge, previous knowledge of what's happening, or the neighbours.
But it depends what's come up in this
Yeah.
survey when they bought the property and what
Yes,
the investigation
yes.
Do you mean private sewer? Private sewer?
Well, you won't get any private sewer records to the general public.
What is a private sewer?
Private sewer is anything within your boundary, your curtilage.
Yeah.
So I've got the drains here.
Yeah.
It goes to that wall. Once it goes over that wall, it's public. This is private, that's public.
But you can get public sewers running under your...
Yes, you can.
Through your house.
Because there's an easement.
So what's the difference? Why do they call that public and then they also call it private?
No, it's a public sewer. It'll be in a private garden, but they'll have an easement. There'll be something on the deeds that say we need access when we want to clean it out and maintain it.
Okay, yeah.
We've got
Alright.
the easement under our we don't watch it up. We've got the easement from our village pub goes under our property.
Yeah. So this is all useful information again.
But no one knows exactly where it goes. But they know it's there.
You can get divining rods
I know.
out there with the old coat hangers.
I pretty much know where it goes. But,
Yeah, but that you're exactly what you're saying. So you need to find all this out. So again, that is more likely to be the connection from the downpipe
That would make sense.
It's a bit tougher looking, so therefore it's a better quality because there's vehicles coming in and out here. But again, I would need keys to lift it up to check it, and I ain't got keys.
Yeah. So the ones that you see, because in our house there's like an inspection chamber and it's just like, it's only like this deep, I think.
That's purely...
Is that just from the roof?
Could be from the roof, could be from your sink and your bathrooms and all that.
Oh, okay.
And all it is where the pipes all connect, they need to put a chamber in there.
Yeah, yeah.
And then they need to be able to clean it with cleaning rods if need be. So it's access for that.
I'm so sorry, I've got to go.
That's all right. We're going to finish up in 2 minutes anyway.
Oh, yeah, okay, well, sorry, and I appreciate it. Thank
all right,
you very
hope
much.
it's been
We'll
useful.
See you again in the spring.
In the spring, yeah.
Thank
all right,
you.
cheers now, bye-bye. All right. I think that's about it.
Really interesting.
Yeah, thank you. Yeah.
But there's an awful lot to it, and what happens is you lead on to other things. And I think this was a problem last year, that I was starting to show people how to measure everything and getting bogged down in that. And then with everything else about the T marks and your boundaries and drainage and problems with level, people think there's too much. So even though we've probably covered exactly the same, I've tried to back off with a little technical.
Great.
Yeah, great. Yeah.
All right. I'll go and wash my hands still.
Do you want any of this stuff rounded up? Bring it in.
Yes, please. Yeah, wind it up.
Offset and chain though, what's that?
Chain offset. This is a chain line.
That's the chain. Oh, that's not the
Or a
baseline.
baseline chain line is the same.
Okay.
All right, and in the notes in the handouts, I refer to one of the. So basically, you're laying out a line, and you can call it a baseline, you can call it whatever you're familiar, a chain line.
Yeah.
Because in the old days, it used to be a chain.
Okay. I think that's just, yeah. So
if you go back to what a chain was, it was just a set of links that had on with little markers every metre or 300 feet. So what you do is just measure along that. I mean, obviously not foot trick because we're in metric.
Yeah.
You measure along and just measure off to whatever. So that's your chain and your offset.
I think I just got confused because I saw baseline and then chain, and I thought they were different.
On the baseline, so you're fixing your baseline. And basically it is a line, it's a base to measure from.
Yeah.
And the terminology is come along the chain, or come along the distance of 10 metres on my chain, and I'm offset whatever it is to the face of the building.
Yeah.
Chain, offset. And the other one was trilateration, which is better. So I'm going off at 10 metres, measuring to there, and go along at 12 or 13, measure the same point. I've got the 3 metres between that, and I've got the measurements there. And it fixes it, and it's not going to go anywhere. So if you can apply that to everything.
Yeah.
And the only thing you need to watch about then is having it level. Try and get level as possible.
Yeah.
So if you're getting over steps or whatever, like if we were going to extend this chain line or baseline through there, there's a different ingredient in there, right?
Yeah.
If I pull the chain down to the next station, it goes like it's wrong, right? So the only way I can get a measurement to that is have a spirit level, and I hold it at the same level and then measure, keep that level and measure to the edge of that against my station or my point.
Okay, yeah.
All right, so it's all level.
Yeah.
But you got it perpendicular down to the point.
To a certain tolerance.
So you get rid of this slope.
Okay.
All right.
Yeah. Thank you. Yeah. Well, what's the tolerance though for that level, like 10, 100 mil or something?
It depends on the distance you're doing. Obviously, in a short distance, there could be quite a lot, but.
Yeah.
I'm going to construct a table and load it up to you about, like a 10 metre garden or a 20 metre garden, and if it's a 2 or a 3 metre interval, what is the difference in height for that?
Okay.
Oh, that'd be really
Yeah.
That'd be yes, because then you just need to think about it. This is sloping up 3 metres. Every 10 metres I need to add on something to give me the.
Can I ask, is that the illegal ramp?
Yes.
Talking about, that's very.
It's illegal.
Yeah, because if you were like in that wheelchair, you would just go flying.
Yeah. For proper gradient against the difference in height, it'd probably end up where that tree is.
Yeah.
Which then goes over the front of the access into the toilets and everything.
Yeah.
And it's no good because you're introducing another hazard.
Or you'd have to make it kind of snake round.
Yes.
You need a large tolerance for that, a large amount of space, don't you, to get it round?
Yeah.
Is that illegal space you're talking about?
Well, it is big. Cheers.
What bit is that?
Yes, it is. Yes, in a little box. Sorry.
Turn them around.
Well, you gradient because if somebody lets go, they don't want to be flying away. But because that was built probably 20, 30, 40, 50 years ago, nobody said.
Yeah, but lots of footpaths are like that anyway.
But I think Andrew Wilson uses that a quite good example. that you need to have consideration if you got disabled access. How does that impact what you're trying to do here?
And then
All good stuff?
yeah, I have a buggy. I mean, like, I have a son, and I used to work in special school, so...
All right,
yeah,
you
we
understand
had a
all
lot
that.
of- yeah, it's a real...
Well, I had to design mine, and mine goes for about, let's go 5 meters, and I'm raising up only about that much.
Yeah.
And it went out 5 meters. It had to be a certain width. I had to supply hard standing so that you could easily get up. And we've never, in 8-9 years, we've never had anybody come in who used it. So, but you need to have the facility.
Yeah.
After a few, after a few.
Oh, that's really
Right.
important.
All right.
Thanks. Wonderful. Thank you very
All
much.
right, no
for that.
problem.